Now recording. So, welcome to the post-midterm week. Happy to see you all here. Happy to see that most of you survived the midterm. I suppose I should have solicited comments while we were off camera. I've already solicited a certain degree of comments about the midterm, but I guess we need to talk about file I/O, or file uploads. File up I/O we covered quite substantially. So, so here we go. So, all right. So file uploads then. So there are basically a few important and interesting things to discuss with respect to file uploads. First of all, it's just kind of a bad idea, kind of in very general terms. Who do we never trust? The client. So why on earth would we want to accept files from the client? The answer is because we have to. There are some things that we need to accept files to do, in order for people to feel that they are, a part of the, the forum that they're signing up for. They need an avatar photo, and selecting from pre-generated ones. Although, I'm sure the way that people are going to try to make it go in the future, if this isn't already a thing, is to use some kind of AI-generated engine to, generate your avatar photo for you, so that it's all in their own enclosed ecosystem, and that your photo only contains the viruses that the AI system naturally found on the internet and re-implemented for you. So, I mean, there's, in theory, no reason, if the AI system was ingesting, image file-based viruses, why wouldn't it reproduce them, right? Except that it's easier to break something than, keep it together, but anyway, so there are a couple of points about file uploads which I'd like to go over. I want to not have to spend too long on this topic. Some of you may have noticed that when it came to a particular somewhat awkward question on a certain test that occurred recently, there was a fair amount of code that was given to you in that question, right? The reason for that is that a lot of the code is quite boilerplate in PHP. There's not a whole lot of modification of the source code which is really useful or necessary when doing file uploads. It's very here's the code, copy paste it, and basically there was an exam question that was considered last semester that was do a file upload, but here on a test, and it's well, basically I'm really only testing if they put that code on their cheat sheet. That's the entire extent of the question. So maybe it's not a good question, so I left it off. But enough of the meta commentary. So files, when uploaded to the server, are the body of a post request, or at least part of the body of a post request. URL parameters are certainly not big enough to accommodate a file, at least not a file of any size. The other thing is that files are very often not text data, right? They're not necessarily character encoded. A great deal of it, will be binary encoded. What sort of files are binary encoded, my children?
Images.
Images, anything else?
Executable.
Executables, anything else?
Audio.
Audio, that's right. And what do you get when you put images and audio together?
Video.
Video files. There you go. So those are the most like media files in general tend to be binary encoded because they tend to be large, and if they were character encoded, that would be like an extraordinary increase to their file size. You should take a look at some of the old how some of these old formats are encoded. Like bitmaps are kind of interesting to look at because they're very understandable, but they're huge, you know. So we've all used file uploads. All of you have submitted assignments, I presume. Otherwise, you wouldn't be in third semester. So you all know what the widget looks like. It's like the upload file button, right? You click that, it brings up your operating system's select file dialog. You select a file, it uploads it, takes the file, places it into the post message body, fires that off to the server as part of the request. So how does PHP handle this? Well, PHP handles files in much the same way that it handles pretty much everything else. You have a superglobal for that. The superglobal is _files. Very good. It's possible to upload more than one file in one request. So, you know, you've got a whole superglobal. The superglobal does not, however, contain the file itself. This is a somewhat important thing to understand. The way that an Apache server handles this, and the way that PHP handles this, you have a separate folder where uploaded files are stored, right? It's given a temporary name, and if you want to take that file and put it somewhere else, maybe send it off to a database as part of the middleware feature. Maybe you want to store it into a subdirectory on your server or something like that. Unless you have an explicit operation which moves the file somewhere, that file is temporary and will be deleted. Make sense? Very good. So the name that is temporarily given to the file is called tmp_name, temporary name. This is where you may find the file. If we scroll down just a little tiny amount to the bit that's got the actual code for the file upload, you'll notice we have files at user file at temporary name. Now, this is a little bit, this is not quite what you would expect this to be. This is not the file name as given by the user, right? In the same way that with a GET request, we have a name for the input element in the web form, and that name gets transferred through as the access name for the GET superglobal. So too here, when you write a form where you upload files, you give a name, you the developer, give a name to that input element. That's where this comes in. You actually don't want to you don't want to take in user file names as given. Because, believe it or not, a file name itself can be a form of security vulnerability. So, this is kind of an interesting one in the way that it works. This, oh man, I left most of my markers somewhere else. All right, that's okay. We'll make do with red. Directory traversal attack. Directory traversal attack. So, in order to understand how a directory traversal attack works, you must first understand just a tiny slight amount about how Unix file systems work. So, let's say, just for the sake of argument, a user uploads a file. Let's call it, avatar.png. Right? Sure. Avatar.png. What your server will do, inside of a temporary folder, it takes the uploaded file and it stores it here with a scrambled file name. Right? abc123 dot xyz. Right? Scrambled file name. The file name that this thing came with is still available to you, though. That's available in the file's superglobal. So, you may be tempted, let's say this is temp, you may be tempted to do something like, well, in my local file system on this server, I have a folder here for avatars. Why would I not just take this file name and make it so that I have avatar.png or whatever inside of my folder of avatars? This seems like a reasonable thing to do, right? So, a couple of reasons not to do this, all right? What's one?
You can go to the root file system. You can have the slashes in.
Yes.
If you put in directory traversing characters, it'll just read them.
Yes. There's another reason that you don't want to do this, though, and it's kind of like unrelated to security issues. What if two people upload two files with the same file name? Right? That's right. You'll run into a conflict. The new file will overwrite the old one, and then young software developer professionals on your LinkedIn profile, you may have this wonderful photo shoot, graduation photo version of yourself available for work, right? And you can suddenly log in one day. And it's like, literally a photo of someone's great-grandmother. And you're like, wow, Agnes is a software developer now? That's great. Good for her. They say that old people don't know computers, but not Agnes. Basically, in order to make sure that you don't run into conflicts, you're going to have to give these things unique names anyways. The temporary name is actually not a bad one to use in this case because, it's a randomly generated string. There's not going to be a huge probability of conflict, right? For reasons that we'll get into when we start talking about cryptography, which hopefully won't be too long. But, by the way, congratulations. You've made it to the interesting half of this class. Everything past the midterm is interesting in this class. because we're going to talk about like sessions and how cryptography works and how a password system is supposed to work and all kinds of fun stuff like that.
If your file upload system was like implemented sufficiently bad enough, they'd use traversal to overwrite like vital files in your program and then just like crash your whole site.
Oh yeah. Oh yeah. Okay, but I have to explain one thing first because, you know, I understand there may be people in this room that have a Linux deficiency. So we have to address the Linux deficiencies in the room before we proceed. It's not your fault. It's the culture you were raised in. So in Unix/Linux, there is a very special combination of characters you can use inside of a file path. First, the first thing to realize is that all file names are truly file paths, right? You can always throw folders on the front here and everything will still work, right? But dot means up one level, right? So if I say, you know, something innocent like, you know, cat, you know, text, right? Then this is a Unix command to elevate myself one level in the directory hierarchy, go to the parent folder, and print the contents or concatenate contents of the file text.txt, right? So this thing has many innocent uses, right? But let's imagine that, you know, we have this hanging out here. All of these guys are hanging out in, you know, a folder corresponding to the page, right? Maybe just public HTML. And let's say that right about here is good old index.php. Right? Let me ask you a question. What do you think happens if this thing is /index.php?
You overwrite it?
That's right. Your program may be intending to place the file into the avatars folder, but the ... here elevates you one level. You then overwrite index.php, probably a bad thing. Like, I would venture so far as to say, in 100% of cases, that's a problem, right? So.
I feel very bad for the first person who found out that this was a problem.
Yes, the first person who found out like that this is a problem is kind of in the same category as the first guy who figured out that like you can't eat nightshade, you know. So, all right, how do we not do that, right? Well, like, you can be fussy about sanitizing the name that they've given you, right? But ultimately, you're going to want to assign your own name anyways to, you know, interfere with people providing the same file name twice anyways. So really, just don't use it. Just don't use the file name that they give you. Simple as. Okay. Would you like to hear another reason why Canvas is awful?
Can you do this on Canvas?
Well, I don't know if you'd be able to do it on Canvas. and I think it's illegal to try. I think it's illegal to try. But let me tell you some of the observations which I have observed for the way that file uploads work in your assignment submission system. Number one, you may notice. Have you ever noticed that Canvas, like, will randomly append, like, -2, -3?
Yes.
Yes.
It stores all your separate submissions in one folder.
Yeah, that must be what it's doing, is it's taking all of your submissions and storing them in one folder. But more than that, it must be preserving their file names. Right? Because this problem wouldn't occur if they were using random file names. Right?
They could be using the file name as a key, sort of randomized.
I mean, if you were using file names as a key and there was some kind of software middleware layer here, then why wouldn't you also use the submission time, like the submission ID as part of the distinguishing feature for the file, right? You could look up by submission ID and then by file name. So there's no reason for the system to be appending -number to anything. Why is it doing this? Probably because it's preserving file names. So if you're wondering, how, does bad programming exist out there? The answer is definitely yes. It is my hope, my aspiration, that all of you will be put out into the workforce as more intelligent programmers than that, and that means having some understanding of these types of issues. By the way, I've gotten sufficiently far into writing the Node course to have attempted to produce a working example of a directory traversal attack in Node. It's very difficult to pull off. Node has a lot of really good inbuilt protections against this kind of nonsense, but not so PHP. PHP will just let you do it. So that's another reason. You thought that you should use new systems because they're easier to use, but it turns out you should use new systems because they're also more secure too.
It's a little bit hard to hear you talk about Node.js like this. It's like we're currently eating a bowl of burnt baked beans, and you're telling us about the filet mignon you're preparing on the side.
You guys want to see the slides I have so far? I can publish the slides I have so far. I'm happy to do so. I mean, I have enough. Maybe right at the end of the course, maybe I'll give you the intro on Node. We'll see how it goes. Normally, the last 2 weeks of this course, I do a full-fledged MVC. We make Twitter. That's the last 2 weeks of this course. So, but the last week is usually exam review anyway. But I digress. Yeah, I apologize. I wish I wish I were presenting a better course to you. But
It's okay. I know you fought for it last semester.
yeah, the course that could have been. That's okay. So yeah, the directory traversal attacks. If you just trust file paths that are given to you, this is actually not even. This is not even an overwriting index is not even an intelligent way to do this. That's not even an intelligent hack, because you would be found out very quickly, A better hack is to read the contents of the server's passwords file, or something like that, where you can just literally, this is what you do. You go in, you get the passwords, you log in using the passwords, you encrypt everything, and you demand millions of dollars. And that's how a ransomware attack works.
Well, it's because they're being stupid and storing raw passwords and not hashes.
Yes. Well, it depends though. Like I'm talking about like the administrator password to the server,
Oh, okay.
right? I'm not sure how Unix stores that. It's likely got at least some level of security on it. But I mean, with Unix, if you have sudo privileges, then you know you can do pretty much anything you like. But yeah, anyway. So, directory traversal attacks, right? So another thing, basically, when it comes to file uploads, aside from like moving the file to where you want it to be, most of the file upload stuff is like, okay, and now check that it is what it's supposed to be. So let's discuss some of the other fields in the files superglobal. Although, before I do, I'd just like to, one or two other things. When moving the file, there's a special function for it, move uploaded file, right? It takes just the plain temporary file name and then moves it to the location that you specify. In this case, uploads. You'll notice that this is doing like precisely the thing I said not to do, actually. Taking the actual, well, okay, it's doing one thing more. It's taking base name of the file, which in theory chops everything from this / on that way off and leaves you just the base name of the file. So in file path parlance, right, the path is all of the folders and the base name is what you think of as the file name, right? So the base name function takes just the file name. But, you know, it's a bad idea. It's just don't do it. Just don't do it. It's not a good idea. You know, because this is completely vulnerable to file conflict. It's fine if it's like an assignment for school, but don't ever put this in production code. So, yes. The HTML code, which is required to make this work, is given here. Input name, user file, type file. There is a file input type, right? So, yes. So, there are a couple of things that may be of particular interest to this group. A couple of other pieces of information which you can find in the files superglobal include the type of the file which has been uploaded. That would be the MIME type. Do you guys know what MIME types are? Yes? No?
Heard of it, forgot what the acronym stands for.
Yeah, I don't know what it's not, no. So, basically, there's a kind of a strange mapping from file extensions to like these phrases, you know, it's like group of file types / particular file type. So among text files, CSS files and CSV files are both types of stuff. Application, gzip, image, GIF, you know, these are all of your MIME types. So basically when you're verifying that something is, for example, an MP3, you're just kind of comparing the string output of files at the particular file at type with the string here. So that's it. Does that make sense? Questions about that? Alright. Size is similar. It gives you the size in bytes. So, you know, if you are expecting, you know, something under 10 kilobytes and someone is attempting to upload something that is multiple gigabytes, you're probably like, there's something sufficiently wrong for you to be like, that's not a good file. Now, this is kind of like the type of vector that like a DDoS attack might occur with, right? So let's talk about protecting yourself from people spamming you with massive, massive files, right? So first, what's the problem? If lots of people decide to upload very large files to you at the same time, right, it causes an extraordinary amount of server traffic, and that can take a server down. It, you know, probably means that you're not servicing other requests that you're getting while you're you know, uploading these mega files, right? So what can you do? Well, there are a couple of things you can do to mitigate, but there's no real way to prevent it. You can certainly build stuff in on the client side to check to see how big the file is before you send it to the server. This is good and prudent. You can check it in PHP to see how big the file is, which is good, but only occurs after the thing has already been dumped into the server's file system. The upload has at this point already occurred on the network, right? Okay. There is one other place that you can fix this, and that is in php.ini. So this is somewhat passing beyond our ken as software developers. This is somewhat entering into the realm of the networking guys, because this is now server administration, right? The networking folks take many courses on server administration, but one of the values that you can set inside of your server's PHP initialization script is what the maximum size of a file upload should be, right? If you constrain that down to the point where it's actually needed, then that's better, right? Don't give it more than it needs. Now that has, of course, problems. It's quite common with Apache servers that you have multiple users who are all relying on the same server to serve their web pages, right? Kind of similarly to how CS Unix works. So the problem with configuring the server for your particular application in a traditional sense is that you may not be the only person who needs those rules to be in a certain state. And you could break one of, you know, you could break someone else's web page if you were given access to that. Generally, you won't have permissions to modify it, right? Whoever you're renting server space from, they have permissions to modify that. You don't, right? So it may not even be in your power. That being said, let's talk about the Docker revolution, right? So a thing which is increasingly common is that you take something like a PHP application, you containerize it, you basically package it with a little miniaturized version of an Apache server. It's an Apache server that's only for you, and you have full admin access to it. So, in that case, you can do whatever you want to the initialization file. And you're not affecting any other users because you're not sharing the server with anybody else. The server is in a container and you are the only user of that container. So, because if any other user also wants an Apache server or access to an Apache server, you spin them up another container. They can have their container, you can have your container, you can configure them however you wish. And that's the beauty of containers. Well, that's only half. That's half of 1% of the beauty of containers. But that is what containers make possible, right? Does this make sense? Cool. Everybody should learn Docker. Docker is currently doing to the industry what virtualization did 15, 20 years ago. It's going to quickly get to the point where if you don't know Docker, then can you even consider yourself to be a back-end developer? Yes?
Is Docker something that will be covered in tools and practices? Like
No, it's too new,
Ah,
unfortunately. I can recommend you a good textbook, but I'm going to do it to you again. In my node rewrite, Docker is in there, but yeah. Although, like that far is actually in like the slide material that I should put up for you guys. How to use it and that sort of thing. But yeah, it's kind of like up to this point you haven't really had a purpose for it though, right? Like until you learn enough about servers to be able to say, oh, I know what the thing a web application is supposed to go in is. Like there's not a huge amount of reason to like mess around with Docker until you at least get that far. So don't kick yourself for not having been into it already because you it's only just becoming relevant to you. So yeah, anyway. I mean, Docker has like a huge number of uses beside web, but anyway, I digress. Yeah, so I think that's as much of a treatment of file uploads as I would like to give at this time. Are there any questions? Okay. Cookies! All right. Cookies. I don't know where they got these new markers, but they're awful. Look at this. I must make a note to complain to Sarah about the new markers. All right. That's acceptable. So, cookies. Does anybody know, tell me what you know about cookies. Cookies seem to always be somewhat mysterious. Yes?
They're used to simplify the process of verifying certain information on the back end.
They're used to streamline the process of verifying certain types of information. Yes. True. That's one of the major uses of them.
They also kind of save data about you when you access a web page. For example, you might have browser-specific user settings for a website, and that will be saved in your browser for that website, and that'll be a cookie. And if you delete it, then those settings go poof and you gotta set them again.
Yes. Certain types of settings for websites are stored in cookies. There are various reasons that this is like not the greatest plan, but it's still quite commonly done. Yes?
They store data on the client's computer and are often used for tracking.
They store data on the client's computer and are often used for tracking. And I assume there's a great big, like, squiggly underline under tracking with a skull and crossbones written at the end of it, right? Yes, the third-party tracking cookie is something that we are going to be discussing. How that works. So, let's go through the mechanics, the actual mechanics of what a cookie actually is, how it gets passed around, and later we will develop that into how do sessions work. All right? So way back in the olden golden days when the internet was free, one of the things that was explicitly built into the structure of the internet from its earliest inception was the idea of anonymous access, right? You can read articles that the Greybeards wrote to this day. By the way, Greybeards are like anybody who worked on computers in like the 60s, 70s, or 80s. So when the Greybeards set up the internet, they set it up so that when a computer makes a request of another computer, it does not require any credentials to do so, right? The free and open internet, right? Now, as time went along, and the internet sort of shifted from this initial conception of like a huge distributed library used primarily by academics, and shifted into the business applications of the internet. It gradually, basically, like the system that the Greybeards set up was far too useful for the amount of anonymity that they originally gave it. One of the first problems that you sort of encountered was, the government wants to use this cool internet thing for people to send their taxes in instead of by mail. You know this postal strike thing that's going on? It's been a long time coming. Like the government has been conspiring to eliminate the post office for the better part of like 30 or 40 years, right? So we needed some way to verify a user. Am I the user I say I am? Am I the person I say I am? Sure. There's no way to do that in the original internet. It's simply not architecturally possible, right? Until the development of the cookie. So this is why cookies are like you know, if you're talking to people who sort of are, you know, I don't know, if you wanna, if there's like a D&D alignment chart for like developers, right? You've got, you still have like good versus evil, but you also have like open source versus proprietary. So the people who are aligned to open source, yeah, I consider myself to be open source neutral. People in this sort of category, I forget where I was even going with that. There's a reason that like the concept of a cookie is associated with the concept of evil, right? Like people think of cookies as being evil, and this is true because they are, you know, like the purpose of cookies is to take the free and open internet and to make it a lot less free and a lot less open. So, you know, it's like a values alignment thing to consider cookies evil. That being said, without cookies, there's a heck of a lot of stuff that goes on the internet that wouldn't otherwise. And you know, it all kind of depends on whether you think that like the internet was a mistake. You know, if you think the internet was a mistake, then certainly cookies were a mistake. But you know, if you like the internet and the things it does, and you don't think it's, you know, propagating too much evil into the world, then you know, perhaps cookies are okay. But so cookies are very, very simple in concept, though. All you're doing is you are storing a key value pair in the browser. That's it, right? So, I think that might not actually work. I'll use the awful red one. So, we have our erstwhile client, represented as always by an antiquated CRT monitor. We have our server, a rectangle with blinky lights, as demonstrated during our field trip. Client makes request. At this point, we don't even necessarily care what. Server sends response, but attached to the response is a cookie. Yeah! Stupid bloody thing. Oh, I hate you. There. All right. I always represent a cookie as a dot with a circle with a series of dots inside of it. So a cookie is a key value pair. Something like ID is equal to 7. Right? Now, when the cookie is received by the client software, it is stored. So I would like everybody to imagine that your browser has a great big cookie jar, right? That looks a little bit like a pot from The Legend of Zelda. Right? The cookie goes in the jar. Now, okay, now the client has a cookie. It stores the key value pair. How does that key value pair make it back to the server? Well, imagine you have, instead of one cookie jar, a series of cookie jars, one for each domain that you're accessing. So for example, this is the cookie jar for CS Unix, right? Anytime the browser sends an additional request to this domain, it gives up all its cookies too. So all of the cookies in the cookie jar are copied and sent to the server with the next request. ID is equal to 7. So, in order for the server to receive the cookie, 2 requests have to be made from the client. Right? One will not have a cookie. The first one will not have a cookie. The server then issues the cookie in the response. All subsequent connections, requests, will contain that cookie. Does that make sense? So far so good? Alright. So, limiting factors. Cookies go bad. Right? You can imagine that, that information may not be good for all time, right? Cookies have an inbuilt expiry, right? Most cookies, at least use PHP and using Apache, default to expiring in, I believe, 22 minutes after issuing. That's the default value. But you can set that, that's a configurable thing, you can set that timeout to whenever you like, and in fact, you can disable it altogether. So you can, in effect, produce a permanent cookie, right? Now, this is not good hygiene or habit, but lots and lots of places and people do it, right? This is basically the fact that not everybody sets an expiry for their cookies is the reason you have to go through and clean your cookies out every once in a while. Yes?
So when you access a website that has like a user account and password or whatever, and you log out, but then you return to that website later on, and it auto-suggests that your password is that a cookie that never expires?
No, that's different. That's autocomplete form data, which is also something that the browsers keep these days.
Okay.
It's not supposed to do that with passwords. It's not supposed to do that with passwords unless you've set up a password manager.
Okay.
But yes, like fill in your address when you're doing shipping, that type of thing. Basically, it's just kind of a side routine where the browser notices when you have used a web form with a name that has basically, if you're in a web form and you have an input of a particular type with a particular name, it keeps track of what you put in there and suggests that to you the next time. This is why it works on some websites but not on others, right? The websites that it works on use the same name for that field, right? You may also consider that to be a security violation. You can disable this on browsers, it's in the settings. I know, for me personally, I've never actually done this, of course, but you ever have that thing where like you accidentally enter your password into your username, right? And then you press enter, and then it's like, oh look, my password is in the autocomplete form data. That's problematic. And then it's like kind of a pain in the ass to go and delete it. It's like it's more secure to just not keep that form data and to just have to re-enter it yourself. It does not, I think, have the same level of encryption and security applied to it that a usual password manager would typically. So yeah, autocomplete form data. When it comes to computers, you should always be suspicious. You should always be suspicious of anybody who's trying to make your life easy, or anything that's trying to make your life easy, because probably they're causing a security vulnerability. Because good security is hard and difficult and takes time, and the time it takes is the time it takes you to enter your goddamn 30-character password in front of your class every single day. So, or at least on the days you have class. So, by the way, we're going to get into why my password is so long. That's a topic we're going to talk about later on. Again, this is the interesting half of the course. All right. So the cookie is sent back. Cookies can expire, right? But often they don't. This is why it's important to clear your cache, right? Because you don't know, generally, who has and who has not expired their cookies. You guys want to look at some cookies? I didn't actually bring cookies. I always forget when, like, one of these days one of these semesters I'm gonna remember to bring cookies when we talk about cookies. Sadly not today though. I know, just disappointment after disappointment today, right? You know, your analogy of PHP as like baked beans is pretty good, because like it does make me gassy, but in the sense that I'm a huge windbag. So, you know, I'd have less awful security vulnerabilities to talk about if we had a language with fewer awful security vulnerabilities. So, let me show you how to view a cookie. If you go to your inspector pane, this is somewhat browser dependent. It's in roughly the same place everywhere. But your application tab in Chrome and Chromium-based browsers, you'll notice over here, oh look, cookies. There you go. My canvas. There you go. These are cookies. Cookie name, canvas session, for instance. ID value. Technically speaking, even with the ... here, it's actually kind of a really ridiculously huge security vulnerability if I were live streaming this, right? But because it's this is a pre-recorded video, this token will no longer be valid by the time this video is published. But I won't extend this all of the way, because then each one of you in this room could do a cookie theft attack on me and give yourself 100% in every evaluation. So, but that's kind of getting into a security topic that I'm going to be discussing. So, these are cookies. Cookies can be modified. You can make up cookies. Oh look, I have a new cookie. It's just that easy. You want to break your session? Done. Session broken. Reload page. I guess I didn't break all the cookies. So, the astute of you may note that there are actually two of these going on, right? So, who do we never trust? We never trust the client. You may think that a cookie issued by the server is safe. If it has touched a client's machine, it is not safe. Clients have full read-write access to these puppies. Just because you sent it in one state does not mean it returns to you that way, right? So don't trust cookies. Cookies, if you're storing like actual like string data in a cookie, which I don't recommend, you gotta filter it before you use it, hands down, right? Everything, like, you should consider this to be the same level of security as like a get parameter, right? None whatsoever. Do not trust this. Do not trust these. Okay? Good? That being said, you'll notice that aside from this guy, not many of the cookies we have are like, you know, this is like last known canvas host. That's interesting. These ones at least, these are random strings, right? There's a good reason those are random strings, and it has to do with cryptography. So, class ends at 3, right? Yeah. I sometimes lose track. You know, time flies when you're having fun. So, that is that like these are cookies in the wild. Let's create a cookie. If everybody could please load up XAMPP. Now I warn you, setting cookies is something that you will probably almost never do. Mostly what the cookie will be used for is to set up a session, and that is handled by the session handling functions. So manually modifying cookies, it's like something you need to know how to do, but it doesn't come up too much, kind of in practical terms. Most of the time, like, you shouldn't really store data on the client, you know? That's what the database is for, you know? So, starting Apache. So let's make a new file. XAMPP. htdocs. Let's make a new folder. Wow. Today is my daughter's 3rd birthday. She's very cute. Cookie demo. .php. She's so cute. Like, everybody is like saying, "Happy birthday, Dee Dee," and she's saying, "Happy birthday to you!"
Oh no, it's like when you go to Tim Hortons and order something and enjoy your meal, and like, "Are you too?"
Yeah. Yeah, exactly. And like, my 4.5-year-old is like, "It's not my birthday, it's your birthday." And she's just like, "Happy birthday!" She's so bouncy. 3 is a really bouncy age. Okay, so Setting cookies is easy. There is the set cookie function. Let us consult php.net. It's no underscore, that's the reason. Yeah, there we go. There we go. So there are a few different options which you can set for the cookie. Name and value are obvious, right? That's the key and the value of the key-value pair. Expires or options, you can manually set the expiry. Set path and domain, these are things that you don't really have to worry about. These two are kind of interesting though. Secure and HTTP only. So, I'm not quite sure what secure does. I'm sure you could get there by reading the documentation. It is somewhat interesting to me that its default value is false. Security is off by default in PHP. HTTP only, I do know what that one does. It prevents JavaScript from reading the cookie. Right? It's easy peasy to read the cookies out of a document in JavaScript. In fact, I will show you how to do so as soon as we have set a cookie. Let us set a cookie. Chocolate chip says hello world. And let's just leave that at that for now. Save. Opening up our browser, local host NAD slash 2025-10-27. There we go. Cookie demo. Boop. Of course, nothing shows up, but if we take a look, ta-da! You can see we've got some character encoding going on with the space and with the exclamation mark, but otherwise this is perfectly legible data. Make sense? So far so good? Easy enough, right? So, that's how easy that is in JavaScript to access. Chocolate chip equals hello world. Or sorry, that's the output. Pardon me. It's as easy as saying document.cookie, and that gives you all of the cookies. All right? This is a problem. So, let's set secure equals true and HTTP only equals true. I think this is how you do this. Let me just check to see if this works on the syntax error. Good. Yeah.
It's not equal, it's good.
So, expiry, set the expiry to, so it's, okay, let's just go through it in order. So, cookie expiry, all right? You are not setting the expiry for X number of seconds in the future. You are setting the expiry for the Unix epoch timestamp at which the cookie will expire. So perhaps time plus, 10,000 seconds. Time is a function which returns the current Unix epoch time. Do you guys know what Unix epoch time is?
It was in the Tom Scott video, right, where it's like the seconds from 1970 January 1st or whatever?
That's right!
Yeah.
I showed you that video. Although I showed you that video in databases, so it's possible some of you didn't see it. So, first of all, there is a hilarious video Tom Scott does, like the reason you never implement a calendar application yourself. But, secondly, Unix epoch time. Alright? Unix epoch time is a 32-bit signed integer where 0 is the first second of the 1st of January 1970, which, as we all know, is the beginning of time. At least for us. I don't know what those other people are thinking. So, every second that elapses, 1 is added to Unix epoch time. Right? And that's more or less it. It's fairly simple. The only problem with that, what happens when you run out of room in a 32-bit integer?
It goes into the negatives.
Yeah, it overflows. This is called the Unix epoch bug. It's coming up.
Oh, this is the next Y2K.
Yeah, well, it's actually a lot worse than Y2K. So, let's see. Unix epoch time bug countdown. Here we go. There we go. There are 4,466 days, 8 hours, 57 minutes, and 44 seconds until the world explodes. You heard about the Aztec apocalypse in 2012? Well, this is going to be worse than that. So
That's ominous.
this is the countdown to the point in the timeline where the universe that decided to use 64 bits for this number delays this problem for a few million years. But we, poor saps who ended up in the universe where they used 32 bits for this number, at this point time wraps around and becomes, I think, sometime in March of 1901. Alright? Actually, let's see. How many years is that? Let's see. Alright, so 12 years from now. Is that right? Am I right? No.
Nice.
For
Yeah, 2038.
The world when
One more. There we go. So 12.23 years from now. Alright? Many of you are probably, how many of you were born after the turn of the millennium? Yeah, so you guys have no memory of Y2K, right? I'm sure you heard about it though, right?
I had to live through the sort of the same panic in the school computers updating all
Yes.
the years.
How many people in the room remember Y2K? I remember Y2K. Oh man, it was quite the craze. I know I'm kind of asking people to call themselves, thank you, fellow old person. So Y2K was this very interesting period because there was a bit of a panic in the year 1999. Very interesting times. You would see like software. You know how like it's like, you know, on a cereal box, it'll say bran flakes now with more bran, right? They would put stickers on CD-ROMs that said Y2K compatible, and it's like, well, of course it is. It's an operating system problem. It has nothing to do with your software. It was, you know, but that's like the panic that like what the Y2K thing had like managed to like stream down to the level of the normies, and like normies were worried about Y2K, so you could sell normies things with stickers on them that said, you know, your Y2K compatible bran flakes.
So it's like the gluten diet fad, where you have all these foods that are gluten-free, and they put on the box and say, now gluten-free, to try and cash in on the craze.
Yes, this was happening with like, you know, Chestmaster 95, 99 and stuff like that. This types of stuff you used to buy on CD-ROMs. So yeah, so Y2K was a problem where basically they didn't anticipate that the computer would still be around at the turn of the century, turn of the millennium, and they only left like two. They only left room for 2 digits in like the year for the number representing the year, right? So it was just like 98, 99, 00. Like computers might have gone to, you know, the year 1900. But here's the thing, guys. That one was software. Software can be patched. Talk to Simon Galton about this. He knows people who like were working like triple overtime in 1999 working in IT and managed to retire on the amount of money that they made fixing Y2K. He knows people, right? Here's the thing about the Unix epoch bug, alright? Any of you know what a real-time clock chip is? First, it's not software, it's hardware. Dun dun dun. So, if you can, basically, hopefully someone in this room has 12 years to develop a way of patching hardware.
So does this basically destroy any computer that uses 32 bits?
Well, see, it's interesting. No, it just destroys many more computers than that. It is true that most computers are using 32-bit architecture. Most computers are using 64-bit architecture and have for a very long time. For Pete's sake, why do you think they called the N64 the N64? Right? 64-bit architecture. No, the problem is a lot stronger than that. Basically, the real-time clock chip is an integrated circuit that was built into a very large number of motherboards, and like, like digital wristwatches? That's the chip in the watch that actually keeps the time, is the real-time clock chip most of the time, right? So like your wristwatch runs at Unix epoch time.
So most motherboards, which have like their internal clock that CMOS battery powers, is that the?
Yes, that's the one. Yeah, so the classic example I like to give is like Pokemon Gold and Silver, like the original cartridge ones that mostly don't work anymore.
Yeah.
That game, Gold and Silver, had like some interesting new tech stuff. It was back in the day when Pokemon games used to have interesting new tech stuff in every version. Like versus Red and Blue, like Red and Blue, the new tech thing was the link cable. That was cool and used for that game. For Gold and Silver, it was like there was an in-game day-night cycle. Certain events would only happen on certain days of the week. And the reason all of that worked was they included a real-time clock chip onto the circuit board for that game, because when you had cartridge-based games back then, if you open up the plastic casing, it's a circuit board. It's a printed circuit board, right? The game is a circuit board. So, anything with a real-time clock chip in it is fried. And that is most of everything. It's an extremely common IC. it'd be interesting to see whether, you know, this is a glimpse into a world that's probably like, some of you have no idea that this exists, but DigiKey is like where you order like ICs and stuff. RTC. Real-time clocks. There you go. There we go. Let's see here. Leap year, supporting leap year, right? Are you gonna tell me where the it'd be like, okay, you'd have to start reading documentation, but like, I would probably warrant that probably they're not, like they're probably still 32 bits, a lot of them. Let's pick a particular model.
So what's that environment options, ROHS compliant?
Oh, reduction of hazardous materials.
Oh,
Or I guess it's ROHS, so reduction of hazardous stuff. Data sheet. Let me see the data sheet. Ah, there we go. This guy, let me see the data sheet. There we go. Shift register. Yep. Yeah, it's not even telling me. Well, anyway, this is quite the digression. That's even further than my normal digressions. Pulling up DigiKey data sheets, what am I thinking? Anyway, have they switched over to 64-bit? I don't know.
Guess we'll find out in 12
This-
years.
They still got 12 years to go, man. How can you possibly expect any electronics manufactured today to still be in use 12 years from now? You know? So yeah, Unix epoch bug. If you want to make a lot of money 12 years from now, learn how to fix that, and then you will be able to retire. And I'm not even joking. That is like, that's a thing to look forward to. That is your moneymaker. Plan to spend the entirety of that year going into that bug, working triple overtime shifts to fix the Unix epoch bug, and then retire. And that's what you can do. Just like they did in Y2K. History doesn't repeat itself, but it rhymes. So anyway, will PHP cookies blow up at the point of the Unix epoch bug? Yeah, probably. So just, don't set your cookie, if you're gonna set your cookie expiry, set it for like 11 years in the future, not 12, and you should be fine. Okay? Okay. So, I'm just gonna set path and domain to, that and that. Now, let's turn on security, and let's turn on HTTP only. Good. Now, a thing that you should know about debugging cookies, alright? When you're working on an application that requires cookies, such as Assignment 3, which I'm going to introduce pretty soon, you're probably going to have to go in and manually delete these things a lot, so get used to that as part of your debug process. Alright? It's easy to delete a cookie, just delete it like that. However, if you're trying to delete more than one cookie, I would recommend going into your browser's settings and deleting all cookies, because it's a little bit onerous to go into every single one of them and delete them all individually. Yes?
the AI says you could also delete the cookie by doing a set cookie, but the time is actually in the past.
I mean,
So it's
Yeah.
like, so you'd call the time function and then you put a minus sign.
I mean, you could set the, you could, yes. But then you're modifying your source code to reset your browser so that you can modify your source code so you can set your browser. Why wouldn't you just delete it here? So, yes, the chatbot is technically correct. You can delete a cookie by setting it to have already expired. But, I'm not sure I would ever do that in practice. It's easier to just go here and click delete. Here we go. So you can see, we have our cookie back, and we have a couple of check marks here now. Oh, I hate this interface. There you go. It's HTTP only and secure. Ooh, ah. Document.cookie does not show the cookie. I want everybody to pay careful and close attention to what I'm about to do. Oh, come on. I have to reload the page. Did it reset it? Yeah, whatever. Anyway, you can manually modify that. So it provides some level of protection, but once again, just don't trust it. Don't trust the client. Don't trust anything you send out there, because even if you can't access it by JavaScript, you can access it other ways. Alright. Okay. So that's kind of all there is to say about cookies, actually. Oh, except for reading them. Alright. That's kind of important. Here we go. Very simple. Anybody care to guess what the super global's called?
Dollar sign.
I think it's cookies with an S. Nope.
We're calling it.
No.
We said it, right?
We are. Boop. There we go. Ah. Come on. There we go. Cookie. Now here's an interesting thing, right? Here, I am echoing the cookie that was sent to the server. This script is also resetting the cookie. So, if I modify the cookie value, like that, reload the page, notice the modified value is read from the cookie superglobal, but the value of the cookie within the browser itself is the old value because it's been reset at the same time this was sent. Does that make sense? Any questions about cookies? All right. So, let's talk about assignment 3. Dun dun dun! I hope you enjoy assignment 3. So, once again, this is one of the ones with a working demonstrations of the code. For assignment 3, there are basically like 2 disjoint parts to the assignment, unlike assignment 2 where it was kind of all one conglomeration. You're going to make Conway's Game of Life, and you're going to make an L system generator. There are computer file videos about both of these, which I encourage you to watch. So, Conway's Game of Life. This is Conway's Game of Life. Conway's Game of Life is a very famous cellular automata with basically you have a grid of 1s and 0s, and in the next iteration, whether a cell becomes occupied by a 1 or a 0 is determined by some very simple rules. You iterate those rules over the whole grid, calculating next steps one at a time, and the effect of it is to produce something that looks a little bit like plankton, and that's Conway's Game of Life, right? So the rule is this: you are checking to see how many live cells are adjacent to the cell you are you're calculating for. So, so if you have the cell of interest I, right, and you have a series all around you of either 1s or 0s, if the number of cells adjacent to you, including diagonals, is equal to 2 or 3, your cell, oh, come on, I'm forgetting it. Is it 2 or 3? I want this to be right. There we go. I expect you to watch the video actually for it. Conway's Game of Life, there we go. I expect you to read the Wikipedia article. There we go. So, if a cell has fewer than 2 live neighbors, it dies, if it's alive. If a cell has 2 or 3 live neighbors, then it remains alive. If it has more than 3 live neighbors, it dies as if by overpopulation. And any dead cell with exactly 3 live neighbors becomes live. So, for example, one of the little spinny gadgets that appears in the assignment. You see these guys? These little spinner guys, right? So basically, if you have 1, 1, 1, 0, 0, 0, 0, 0, 0, and zeros otherwise, right? If you examine this guy, right, he only has 1 live neighbor, so he dies. Same with this guy. Well, on the next iteration anyway. That's the one thing that you have to get about this problem, is you can't modify as you go. You have to create a new grid to hold the updated state, because you still need the old state to calculate the new one from. You can't just go through and, right? So this one is 0. This one is 0. This guy, how many live neighbors does he have? 2. So he remains alive. How about this one? How many live neighbors?
3.
1, 2, 3. Remember, we're including diagonals. So he turns to be alive. Same thing on this side, symmetrically. That's why it's doing this kind of like, you know, flip, 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 flip. It's a stable pattern. Right? Does that make sense? So, in terms of like, how does this actually work, right? If you take a look, this is it, right? You are sent, the bits representing the state of the board, right? It depends on, like, okay. There are a couple of these buttons, when you press them, they send the state of the board as it exists to the server. But most of the time, it's not like assignment 2, where that's like bounced back to JavaScript, JavaScript bounces it back. It's not being bounced back and forward like that. The state of the board is being stored in a session on the server, so it's remaining stable. All we're asking for in JavaScript here is an update. Once, like, you know, every half second, go get the next state of the board from the server. The server updates the field of play, sends that updated thing, but during like our normal request, you're not really sending anything actually. So, good. The program has been broken down into a number of PHP scripts. Store board stores the state in the client on the server. Get board retrieves the state from the session and sends that to the server, or sends that to the client. And then, of course, step.php does the actual like simulation of one Conway step over the entire grid. Any questions about this? All of this business to do with sessions will become clear soon. By the end of the week, I hope. We'll at least, like, sessions are not difficult. All right? It's like 2, maybe 3 functions and 1 more super global that has nothing in it unless you put it in it. And that's what a session is. All right? The stuff that goes into it is kind of complex and interesting, but like the actual use of a session itself is pretty, like, it doesn't require a great degree of intelligence. So that's good. We like things when they don't require intelligence. So, good. L systems. So L systems are an interesting, they actually boil down to a string manipulation problem. L system. So, we plant a seed, we grow 1 step, we grow 1 step more, we grow 1 step more, again, and that's it. Try pattern 1. And you can see these things kind of like look somewhat convincingly like plants. You can even switch the patterns halfway between. So this is a fractal engine. You guys know what a fractal is? Hopefully most of you. Anybody not know what a fractal is? Okay, So a fractal is a pattern where when you examine a portion of the pattern, it's the whole pattern again. So a very famous example is the Mandelbrot set. This guy? I think Wikipedia has a, yeah, there you go. So if you zoom in on the Mandelbrot set infinitely, right? It's possible to zoom in on it infinitely because it's a repetition of the same pattern in increasingly small and smaller and smaller sort of volumes. Another famous fractal is the Triforce fractal. So if you have a triangle and you draw a little triangle in it, you can draw little triangles in these triangles, right? You can draw little triangles in these triangles as well, right? That's a fractal as well. And you have interesting mathematical properties of fractals, like if you fully expand this fractal, the object has actually no volume, or very close to no volume, stuff like that, or no area that it takes up. But yeah, so L system. It's not too difficult to implement. That's the interesting thing about these things. So I think I'm going to have to continue this talk next time, but I'll give you the rough intro to it. So basically, you have a few characters in the string, and each of the characters is a type of an instruction. So the simplest is just a letter. A letter corresponds to a line segment, right? By the way, all you have to do is modify the string. Included in the code I've given you is all of the JavaScript that actually draws the thing. You don't have to worry about that. All you have to do is some string substitutions, all right? So the fractal itself, in this case, is A becomes A branch negative A branch positive A. Negative and positive mean angle either clockwise or counterclockwise, right, by a certain amount. That's actually settable in the interface. So when I draw this guy, right, I end up with line segment, start a branch, counterclockwise segment, return, end branch, rotate, draw a new line segment. And that's that Y shape that we had initially, right? Now, I think this one's actually B. So all letters, no matter what they are line segments, but if there's no replacement rule for the next iteration, then it just kind of it's just a dead segment, basically. So if we take this string and we perform this substitution on it again, we end up with B, rotate, A, rotate A, rotate A, positive A, I guess those are B's, aren't they? Pardon me. Negative A, positive A. So we've got two branches. We still have the two branches, but on the ends of each of those branches, another one of these Y shapes has been placed. So this one, when drawn, you have the B first B segment, then open up a branch going this way, B segment, then rotate again, there's an A, there's an A, end branch, then you do the other one. And that's how on each iteration, each of these A branches is replaced with this shape that forms a fractal. That's how the fractal forms. And it turns out this is actually fairly similar to the way that plants actually work in nature, which is kind of cool. Lots of things actually work along these lines in nature. Fractals are everywhere. It's like, I'm sure everybody's observed that if you take a twig and you just kind of squint at it, it looks like the tree it came from, right? It's the same principle, right? So, in terms of the actual programming work going in though, for each step, you receive a string from the client. You perform all of the substitution rules, which, by the way, have been encoded in a JSON file for you. Output the resulting string, and send it back to the client, and that's all that's required for the server. Aside from saving the state of the thing in the session, same as the other. So yeah, couple of fun little math problems for you to work on. Don't worry about working on them just yet. We still need to talk about sessions. But the mathematical guts of these things, right? The Conway adjacency problem and the else system substitution problem are absolutely things that you should be able to do right now. Any questions? Okie dokie. I realize that it's really hard to find a algorithm that's got the Conway algorithm is an extremely famous and popular algorithm. I still encourage you to do it yourself. Please don't cheat because practice stuff. Okay? Alright. Have a good one, kids. Adults. I call everyone kids now.